Okay, so class, now we are going to go through this assignment 10F. As mentioned in class today, we will only cover the MCQ. So we will cover the MCQ of this assignment 10F only because the earlier exercise is also quite long. Okay, so let's look at our assignment 10F MCQ question. What is the correct order of the reaction? So over here, we have a halogenoalkane to an alcohol. So the halogenoalkane only has kind of reaction that is called nucleophilic substitution. And an alcohol to an acid is a form of oxidation. So we'll pair up with oxidation. And the last one is converting an acid into something called ester. So therefore, esterification is a form of condensation reaction. So answer will be A. Question 2. Which is the correct classification of the alcohol? So we need to look at the carbon that has the OH and not any carbon. So you may want to color the carbon first, and then you look at it in terms of how many R group it contains. So the first one, you can see 1, 2, 3 R group, so tertiary, right? The second one, you find that it looks very big, but it has only 1 R group, so primary. So therefore, these are all wrong. And we confirm our answer with the last one, which has 2 R group, so secondary. So answer is B. Question 3. What is the main organic product formed from the reaction of this alcohol with this acid in the presence of an acid catalyst? Alcohol, acid. Right, when we name an ester, because alcohol and acid forms an ester, when we name an ester, we name the alcohol part first, then the acid part. Right, so we can see there are 2 carbon here, so it's an ether. And then here you have 1, 2, 3, 4 carbon here. So it is butyl. So answer will be ethyl butanoate. Okay, question 3 will be A. Question 4 now. Which of the following conditions are used to get a good yield of carboxylic acid? So we want carboxylic acid. Yes, we need to acidify because oxidation is usually carried out under an acidified condition. So we use sulfuric acid. We heat the mixture until it gets fully converted, and we do not distill. Because if we distill, right, we will actually remove it as aldehyde. Then we will not get a good yield of carboxylic acid. So we don't distill. So answer will be 1 and 2 will be A. Question 5. Which is the product of the oxidation of butyl 2-ol? So first sketch your alcohol. Now, sorry, just sketch your alcohol. Now, before we look at it, you need to remember primary alcohol will give you either an acid or aldehyde. Secondary alcohol will give you a ketone. Tertiary alcohol will have no reaction. So if we look at this, okay, and classify the carbon, you will find that yes, 1, 2 groups. So it's a secondary alcohol, we will expect to get a ketone. So answer will be dot. B for dot. Next, let's go to question 6. Which of the following is a product of the vigorous oxidation of the organic compound? So we need to classify the alcohol. So over here, look at this carbon, look at this carbon, and look at this carbon. So the first carbon over here, if you look at it, it has 1H, right? Yes, 1H. So therefore, it's a secondary alcohol. Now, then the next one, if we look at it, surrounding this carbon in the center, you'll find that there's no hydrogen at all. So therefore, this center hydrogen, this center carbon is a tertiary carbon. And next, you can see there's 2 hydrogen here. So we can tell that this is a primary. Now, so secondary one will give me a ketone. Primary, since it's a vigorous oxidation, so it will give me a carboxylic acid. And the tertiary has no reaction. So I will be expecting a ketone carboxylic acid and no reaction. So answer will be A. You have a ketone, I have a carboxylic acid, and I have no reaction. Question 7. Which of the following will be formed when this is distilled with dichromate? So the key word here is distilled. So let's draw out butanol, 1,3-diol. Right. So again, classify first. So you'll find that this is a primary alcohol. And over here, this is a secondary alcohol. So a primary alcohol will give us an aldehyde when we distill, while a secondary alcohol will give us the ketone. So we will expect an answer to contain 1 ketone and 1 aldehyde. So it's B. Question 8. Which of these organic compounds will you expect to have the highest boiling point? So we are looking at strongest intermolecular forces, hydrogen bond. So alcohol consists of hydrogen bond. Ketone is because of its band structure. Okay, so therefore it's PD. Aldehyde has this structure. Again, dipole moments cannot cancel out because they are not equal in magnitude. So it's PD. And the last one, you can see CCl, so there is a polar bond. So the whole molecule will therefore be polar because the dipole moments do not cancel out. So it's PD. So the one which has the highest boiling point will be A. Okay, question 9. The answer will be, so it was the same food coloring. The food coloring was divided into 2 parts. So we have 2 tubes, but both are the same food coloring. So analyze shows that there's a carbonyl. So what are the substances which can be carbonyl? It can be an aldehyde, ketone. Okay, there's a carbonyl group present. And when you add potassium dichromate to the sample, it turns green. So this hint here is telling us that it can be oxidized. The sample can be oxidized. So therefore, our answer will be an aldehyde because a ketone will resist further oxidation, whereas an aldehyde can still be further oxidized to a carboxylic acid. All right, so that's for question. Next one, question 10. Vinegar is prepared by oxidation of ethanol, which is likely to be the product. Okay, so if you oxidize an ethanol, which is a primary alcohol, if you draw out the structure, it's a primary alcohol. So eventually you will get carboxylic acid. So you get ethanoic acid, which is A. All right. Okay, next one. Which of the following reactions can produce 2-methyl propanol? So let's draw out 2-methyl propanol. So it's something like this. So what type of reaction can give me this structure? Now let's look at 1. 1-bromo-2-methyl propane is hydrolyzed. Here the hydrolysis reaction refers to nucleophilic substitution. So when your original 1-bromo-2-methyl undergoes a nucleophilic substitution, then its bromine group will therefore be replaced. So you can actually get this structure, 2-methyl propanol from this nucleophilic substitution reaction. So this hydrolyzed here refers to nucleophilic sub. So we can get it. Now, next one, 2-methyl propanoic acid reacts with LiAlH4. So what is LiAlH4? LiAlH4 is a reducing agent. It reduces something. So what is the substance that is reducing? Let's draw it out. It's going to reduce a 2-methyl propanoic acid. Now, this acid came from a primary alcohol. So when you reduce, naturally, you will be able to get back the primary alcohol. So it's a possible answer. 2-methyl-propanol reacts with hot dichromate. Dichromate over here is an oxidizing agent. Okay, it's not a reducing agent. And propanol, the nal means aldehyde. So when you have an aldehyde and you have an oxidizing agent, you will end up getting a carboxylic acid. So you will not get an alcohol. So therefore, number 3 will be wrong. Answer is 1 and 2. Question 12. Honeybee produces this. How can this be made in the presence of an acid catalyst? So we want to make an ester. How do you know it's an ester? Look for the COO. Okay, now to make an ester, you need to cut it up so that you know what is used to form the ester. So we cut it over here where the COO is. So over here, this portion here is the acid. And this portion here is the alcohol. So we need a 2-carbon acid. And we need a 1, 2, 3, 4, 5 carbon alcohol, right? So try to look for a 2-carbon acid and a 5-carbon alcohol, and there's only one answer, which is C. So you don't even need to consider other things, okay? Now, next one, propanoic acid, butanol or butanol. The compounds are arranged in terms of increasing acidity. So when we say increasing acidity, means this is the lowest, this is the highest, right? Cannot be, right? So it's not an increasing acidity. Decreasing boiling point, yes, because in a propanoic acid, the type of intermolecular force is hydrogen bond, and a butanol is also hydrogen bond, and a butanol, the type of intermolecular force is PD-PD. So propanoic acid, take note, it has the strongest hydrogen bond. Okay, strongest hydrogen bond, more extensive hydrogen bond than butanol. So therefore, propanoic acid will have the highest boiling point and then it decreases. So this is correct. Again, the next part, decreasing solubility in water. Since solubility is about forming hydrogen bond, so the extent and the strength of the hydrogen bond will also decreases as we go down in the same order. So therefore, answer will be 2 and 3. It will be boil. Okay, now 2 more questions to go. The following fragrance material has a fruity scent. What are the possible products when this undergoes acid catalyzed hydrolysis? So first thing, look at this. We can see ester again. Hydrolysis is breaking up the ester using water. So it's breaking up something using water. So if you break up the ester, so basically we have something that looks like this. We have a 2-carbon acid. So we need to find a 2-carbon acid in the answer, and the other part is the alcohol. So therefore, the answer will be B, because it's quite obvious that B is a 2-carbon acid. The rest don't have a 2-carbon acid, and then that was the alcohol. So this was a 2-carbon acid, and this was the alcohol. 15. Which of the following can form hydrogen bonds with water? So to form hydrogen bonds with water, you can see, right, water molecules has the H. It has the O and the H. So it already has the H bonded directly to OFN. And then what we will need is just the lone pair on OFN. Okay, because we already have the hydrogen with the OFN here. We just need the lone pair because hydrogen bonding is a electrostatic attraction between the lone pair on the OFN and the delta positive H that is bonded directly to OFN. So we need to check the structure to look for OFN. So we find that you don't have, and then this is the only one because in a propanoic, this is the RO. which has the lone pair that can act as a form hydrogen bond with the hydrogen in water. Okay, so with that we have finished the MCQ. We'll stop here.